Okay, so let's continue where we left off in the notes in 4.3. So I didn't cover 8, 9, and 10 with you in your notes in 4.3. And this has to do with angle of elevation, angle of depression. Okay, so word problems. So we'll just call angle of elevation theta and then maybe angle of depression beta. So if you have some person right here, and this person has a line of sight, okay? All right, these are his eyes, his or her eyes. And let's say he's looking upward, okay? If he's looking upward right here, the angle that is formed between the line of sight, right, from this observer and this diagonal line right here, right? He's looking up some up on some cliff or mountain or whatever. That's called theta, which is called the angle of elevation, okay? Now, at the same time right here, let's say there's some guy or girl that's standing up here, right? And he or she also has a line of sight, right? Assuming that's where the eyes are. Line of sight, or you can call it the horizontal. If he or she is looking down, the angle between the line of sight and this diagonal line right here, that's called the angle of depression, okay? Angle of depression, we'll call it beta. Angle of elevation, we'll call it theta. All right, now, hopefully you remember this from geometry in Math 1, right? If these lines are parallel, which in fact they are, theta, right, is actually equal to beta, right? Angle of elevation, angle of depression. The measurements are the same because these are parallel lines right here. Both these line of sights are parallel lines. And if you have a transversal that cuts through those parallel lines, right, this angle is actually congruent to this angle. Okay, so that's what the angle of elevation, angle of depression are. And let's take a look at those two problems in your notes. So on number 9, right, it says a 14-meter flagpole casts a 10-meter shadow to point A. All right, so here's my flag, flagpole, okay? And it casts a shadow, 10-meter shadow to point A. So a shadow, right, would look something like this. This will be my shadow, and this will be 10 meters. And here we'll call it point A, okay? It says find the angle of elevation from point A to the top of the flagpole. Okay, so this will be the top of the flagpole. And the question is, what is this angle right here, right? Theta. And so the flagpole itself is 14 meters. And once you have the picture drawn correctly, right, again, this is a right triangle because that flagpole we're going to assume is straight. All right, you're just going to use your tangent ratio, right? You would say tangent of theta is equal to opposite over adjacent, right? 14 over 10. And the way you get theta by itself, right, is you have to take the tan inverse of 14 over 10. Now, when you're doing this on your calculator, make sure you are in degree mode, okay? Check that you're in degree mode in your scientific calculator. And I'm just going to enter this. Tan inverse. Some of you might have to hit the second tan button. If you're having some issues with technology in your calculator, come to tutoring and I can show you how to use it on your calculator. Okay, so about 54.46 degrees. And make sure, again, that you are in degree mode. Okay, so that will be the angle of elevation using your tangent ratio. All right, now moving on to the last problem, number 10. This one requires a little bit more work. It says you are in a hot air balloon that is 600 feet above the ground where you see two people. Okay, so here's my hot air balloon. And it says for part A, if the angle of depression from your line of sight to the person standing at point B is 30 degrees, how far is the person from the point on the ground, below the hot air balloon? Okay. So let's draw this picture here. So let's say you're over here, somewhere in this hot air balloon, and the angle of depression to a person at point B is 30 degrees. Okay, so I'm going to draw this angle. We'll say, hey, this guy right here, right, is 30 degrees. And we'll call this point B. Okay, so if this angle right here is 30 degrees, right? This angle right here would also be 30 degrees. Remember, parallel lines cut by transversal, alternate, these are called alternate interior angles, if you remember the actual name, is 30 degrees. So the question is, how far is the person from the point on the ground below the hot air balloon, right? So the hot air balloon right here is 600 feet, right? And you want to find the distance from from point B to this point on the ground. This would be the quote-unquote point on the ground. All right, so once you have the picture, right, you just basically have a right triangle. You're applying your right triangle trigonometry. And I will use my tangent ratio. Okay, so tangent, and we'll call this B. Okay, so that's what's asking. How far is the person from the point on the ground from the point on the ground below the hot air balloon? Okay, so how far is point B to this point? Okay, so tangent of 30 degrees, right? Opposite over adjacent, 600 over B. If you were to get B by itself, B is 600 over tan 30. Now, it just so happens to be 30 degrees is actually a value on the unit circle. So if you want, right, you could just say, hey, I already know the tangent of 30 degrees. Tangent of 30 on my unit circle, right? The ratio of y over x, when it's at 30 degrees, it's going to be root 3 over 2. 1 half over root 3 over 2, right? 1 half over square root of 3 over 2. And you're just going to get 1 over root 3. So, this should be 600, right? 600 square root of 3, okay? So if you want, you could use, your trig here with your knowledge of the unit circle. But you know what? Let's just get the approximate value. 600 over tan 30 is about 1039.2 feet, okay? So let's just give the approximate value. All right, now, that same picture, right? It says if the angle of depression from your line of sight, which this is you, to the site, to the person standing at point C is 20 degrees. So 20 degrees, right? The angle gets a little bit steeper. So, and we'll call this point C. Okay, so again, this from here to here was 30, so don't get confused. From here to here is now 20. And if from here to here is 20, that means from here to here is 20, right? By alternate interior angles, okay? So again, the question is saying, how far is the person from the point on the ground below the hot air balloon? In other words, how far is person C to this point? So maybe we'll call this distance, we'll call it C. All right, so for part B, again, I'm going to use my tangent ratio, right? The tangent of 20 degrees, right? Opposite over adjacent, 600 over C. And then I just do a little cross multiplication. C is equal to 600 over tan 20, okay? So you can get the approximate value, whatever that is, 600 over tan 20. It looks like you're going to get 1648.48 feet. All right, so let me just get rid of that. There should be in feet. All right, so for part C, right, the question is how far are the two people? How far is C from B, right? What's this distance? Well, if you know some basic geometry, right, if the distance from here to here is C and the distance from here to here is B, right, the way you figure out the distance between C and B is, right, C minus B. And you already have those two values, 1648.48 minus 1039.2 feet. You will get about 609.28 feet. That's how far apart these two people are. Okay, so let me write that a little bit more clear here. All right, so the key when you're doing these angle of elevation, angle of depression problems, obviously, is to be able to draw the picture. Once you have the picture, right, you're just applying right triangle trigonometry.